Have you ever felt like modern life is just a relentless barrage? I mean, between digital overload, chronic stress, and having our attention constantly fragmented, we are more connected than ever, yet somehow increasingly exhausted. It's no wonder millions of people have turned to intermittent fasting. It's been hyped up everywhere as this ultimate biological reset for our overstimulated brains, a way to reclaim peak cognitive performance, build emotional resilience, unlock deep work, and truly optimize healthy aging. But recently, an absolute shockwave hit the medical community. Major headlines started declaring that this exact same practice, the one supposed to save our health, might actually carry a hidden, potentially fatal risk to our hearts. It is a profound, almost dizzying modern lifestyle contradiction.
So, what's really going on here? Are we successfully rewiring our brains for the better, or are we silently damaging our cardiovascular systems in the background? To solve this mystery, we have to look past the clickbait and the viral social media myths. Today, we're going to unpack this biological paradox together, using a deep, interconnected systems biology approach. We need to look at the whole cascade, right? How your micromental health affects your sleep, how your sleep affects your brain health, and how that brain health regulates systemic inflammation throughout your entire body. Let's start by looking at our first major piece of the puzzle: brain fuel and neuroplasticity. To really grasp the deep systemic effects of fasting, we actually have to zoom way in, right down to the microscopic level. Usually your brain is totally dependent on glucose, and thanks to modern ultra-processed diets, that often means massive energy spikes followed by terrible crashes. You know the feeling, that afternoon brain fog where your attention is just entirely fragmented. But look at what happens on this timeline when you fast. Between 12 to 36 hours in, you fundamentally alter your brain's chemistry. First, you deplete your glycogen stores. In response, your liver is forced to adapt, and it starts producing ketones from fatty acids. Your brain then scoops up these ketones and uses them as a highly efficient, cleaner alternative energy source. This metabolic flexibility is a total game changer. It stabilizes your brain function, supports incredible cognitive endurance, and powers the kinds of sustained focus you need for deep work, completely insulating you from those typical modern-day energy crashes. And it gets deeper. As you continue to fast, your body actively suppresses a specific nutrient-sensing growth pathway called mTOR. Now, because most of us rarely experience true hunger anymore, constant snacking is pretty much the norm, the mTOR pathway is almost always stuck in the on position. And that's a problem because it prevents cellular recycling, meaning junk proteins just build up and actually drive biological aging. But fasting temporarily shuts down mTOR, which triggers a vital, absolutely crucial biological process called autophagy. Think of autophagy like an internal cellular cleanup crew. It literally sweeps through the brain, clearing out damaged cells, trashing toxic proteins, and recycling aging mitochondria. This cleanup is a foundational pillar of healthy aging, offering profound protection against neurodegenerative conditions like Alzheimer's disease by keeping your cellular integrity absolutely pristine. Fasting doesn't just clean up the mess, though. It actively builds a better, more resilient brain by ramping up the production of a protein called Brain Derived Neurotrophic Factor, or BDNF. You can think of BDNF as essentially fertilizer for your brain's synapses. It powerfully enhances neuroplasticity, which is your brain's literal ability to adapt, learn, and rewire itself on the fly. But what's even more fascinating is its role in our micromental health. BDNF interacts super closely with the brain's dopamine systems. During the refeeding phase, just after you break a fast, it promotes the physical formation of brand new synapses, which acts as a powerful natural antidepressant. It fundamentally builds emotional resilience, shielding your neural circuits against the relentless digital and environmental stressors we face every single day. And the clinical research absolutely backs this up. Dr. Mark Mattson, who is a leading neuroscientist in this space, found that intermittent fasting actively enhances DNA repair, directly combating the cellular mutations that drive aging. Furthermore, he observed something super interesting. While fasting does take a few weeks for your body to adapt to, once you are adapted, it significantly increases the activity of GABA. Now, GABA is an inhibitory neurotransmitter, and it has a profound natural anti-anxiety effect. It basically acts as a much-needed cooling system for an over-revved brain. By putting the brakes on toxic hyperexcitable states, which, by the way, are tightly linked to burnout, chronic anxiety, and even Alzheimer's pathology, fasting protects your delicate neural networks from essentially burning themselves out. This incredible protective mechanism extends deeply into the realm of genetics and longevity, thanks to a family of proteins known as sirtuins. Fasting specifically upregulates SIRT1 and SIRT3. To understand why this matters, we have to look back at our evolutionary context. You see, sirtuins evolved to protect our ancestors during severe famines.
They essentially trick the body into a state of intense cellular preservation. They enhance synaptic plasticity and fiercely protect the mitochondrial function of your brain cells. By activating these ancient, hardwired survival pathways, fasting actually extends your health span. And remember, health span isn't just about chronological lifespan. It's about maximizing the years of your life lived in robust, resilient physical and cognitive health.
All right, so how does this tie into the rest of the body? Let's dive into section 2, the gut-brain connection.
Because brain health doesn't just happen in isolation up in your head, right? It is dictated by a massive interconnected health system. Fasting dramatically remodels your microbiome. When you practice intermittent fasting, clinical data shows a measurable increase in beneficial bacteria, called firmicutes, alongside a sharp decrease in bacteroides. Why does that matter? Because constant eating and ultra-processed foods artificially inflate the numbers of those bacteroides, which are actually linked to anxiety and a disruption of your natural appetite regulation and intuitive eating. Preclinical studies strongly correlate the specific microbial shift caused by fasting with a remission of anxiety and depression. It's a direct chain reaction. Gut health dictates mood, and mood dictates behavior. Once modified, this newly optimized microbiome literally becomes a dedicated factory for neuroprotective chemicals. For example, fasting increases the production of short-chain fatty acids, like butyrate, which successfully cross the blood-brain barrier to cool down neuroinflammation. Crucially, it also restores your intestinal barrier. This actually reverses a condition known as leaky gut, which is where intestinal permeability allows toxins to seep into your bloodstream, triggering systemic inflammation and severe brain fog. Furthermore, fasting boosts the microbial conversion of tryptophan into indoles. This drives a very specific, complex cellular communication pathway known as AHR signaling, which fundamentally fosters serotonin synthesis and defends your brain against long-term cognitive decline.
But here is the kicker. It's not just about what these microbes produce. It is heavily dependent on when they are active. This is where sleep optimization enters the picture. Time-restricted eating tightly aligns your gut's circadian clock with your body's natural sleep architecture. Late-night eating, on the other hand, fundamentally confuses your body's peripheral clocks, which effectively destroys your deep, restorative recovery sleep. By synchronizing these diurnal rhythms, fasting prevents systemic neural inflammation. Optimized gut timing guarantees optimized sleep, and as we know, optimized sleep is the absolute bedrock of cognitive resilience for the next day.
Let's look at how this plays out in real-world applications. A clinical trial by the Intramural Research Program compared older adults on a 5-2 intermittent fasting diet against those on a standard USDA healthy living diet. Interestingly, both diets successfully improved baseline cognition and even reduced visible signs of brain aging on MRI scans. However, the 5-2 fasting protocol was uniquely potent. It had far stronger effects on reducing insulin resistance, and it directly improved executive function. And executive function is essentially the CEO of your brain. It's the neural network responsible for impulse control, complex problem solving, and your actual capacity to sit down and engage in focused, deep work. Now we have to pivot. Let's move into assessing the hidden risks. We've explored the profound cognitive and anti-aging benefits, right? But in rigorous science, we must confront data that challenges our pre-existing beliefs. And this is the number that sent literal shockwaves through the health world. An American Heart Association abstract revealed a stunning 91% higher risk of cardiovascular death linked specifically to an 8-hour time-restricted eating window. 91%, we have to unpack the evidence behind this massive spike with extreme scientific nuance. So let's look at the data. The AHA study analyzed over 20,000 U.S. adults over an extended period. Now, keep in mind, this was an epidemiological study, meaning it looks for broad patterns across populations. Objectively, the researchers found that limiting food intake to less than 8 hours a day did not associate with living longer overall. But much more alarmingly, the increased risk of cardiovascular death was exceptionally pronounced for individuals who were already living with existing heart disease or cancer. But rigorous science requires rigorous debate, especially when we're trying to distinguish between correlation and causation. Stanford's Dr. Christopher D. Gardner provides some absolutely critical context here. The AHA study has significant limitations that we have to address. First, it relied entirely on a self-reported dietary recall from just 2 days of the participants' lives. 2 days. Furthermore, it completely missed data on nutrient density. Were these individuals breaking their fast with wild-caught salmon, leafy greens, and whole foods? Or were they cramming ultra-processed fast food into those 8 hours? Additionally, we just don't know the baseline stress levels, weight profiles, or the underlying medical reasons why these specific individuals were restricting their eating windows in the first place.
Beyond that epidemiological debate, Harvard Health points out some very real practical dangers of fasting in modern life. First, there is a powerful biological push to overeat or even binge once a fasting window ends. If you lack intuitive eating skills, this triggers a massive insulin spike that completely undoes any of the metabolic benefits we talked about. Also, if your eating window is pushed too late into the night, it causes severe circadian misalignment, driving metabolic trouble. For older adults, skipping meals brings a very real danger of severe, unwanted muscle loss, which is terrible for longevity. And crucially, fasting can dangerously interfere with the metabolism of certain blood pressure or diabetes medications.
So, where does this leave us? Let's look forward to the future of fasting.
The lead author of that AHA study, Dr. Victor Wenza Zhang, actually summarizes the current scientific consensus perfectly with this quote. The future of health optimization is absolutely not about blindly following a one-size-fits-all biohack you saw on social media. Intermittent fasting is a potent physiological stressor, and it is a true medical intervention. The future of wellness relies on tools like continuous glucose monitors, wearable technology, and personalized medicine to track exactly how your specific body responds to that stress. It requires a deep, honest understanding of your baseline health and, frankly, physician oversight to ensure the practice serves your longevity rather than silently degrading it.
Throughout this explainer, we've seen how every system in your body influences every other system. We've seen how fasting clears out cellular debris to boost your mood, how that mood alters your sleep architecture, and how the wrong eating window can unexpectedly stress the heart. So I want you to look closely at your own daily habits. If intermittent fasting has the power to rewire your brain, but also has the potential to stress your cardiovascular system, is your current eating routine truly optimizing your unique biology, or are you just blindly following the clock? It's a lot to think about. Keep questioning the science, keep learning, and most importantly, listen to your body.